lesson, we're going to be looking at Karnaugh Maps. You should already have an understanding of Boolean logic and Boolean expressions. If not, you need to look at the previous video on what Boolean expressions are. Remember, we use logic gates to draw out circuits, and the symbols are shown on the right hand side. You can see here is an XOR, not A or B, and you can see the table that we've used. Now, when engineers create computers, it can be massively complicated. We want to use the least number of possible Boolean gates because this is going to reduce the cost, the size, the power consumption, and improves execution speed. Karnaugh Maps provide us a simplified method that we can simplify Boolean expressions. So here you can see a truth table. Can you think what logic gate this represents? Hopefully you've spotted that this is an OR gate. So here is a quick truth table. You can see we've got three inputs here. We've got A, B and C. So we've got A and B or C with an output which is P. Now, to simplify this, we can actually create a Karnaugh map. And you can see how much simplified the Karnaugh map is compared to the truth table. We look at A and B as one input, rather than A and B as separate inputs. They both link into one logic gate. So in this circumstance, we can create them as one input. So notice how we put A and B in the top left-hand column. You can see each input or each variable is placed in this position. And to help us understand Karnaugh Maps, we're just going to use two inputs to start with. So A goes down the column and B goes across the row. You can see our truth table on the left-hand side. You can then have a look at the different states for each of the variables when they're on or when they're off. Think of the output of P. So when both A or B are on, that means there are three states which would give an output of 1. When either of the inputs are 1 or when both of the inputs are 1. So we represent these with 1s in the Karnaugh map. The great thing about a Karnaugh map is it can also help us to simplify an expression. So here we've got not A or B. So your task is to try and complete this Karnaugh map. Now, when we want to create our Karnaugh map, we need to think about simplifying our expression. You'll understand this more as we look at more complex expressions. But the first thing we want to do is divide the expression into the two parts. So through our OR. So we've got not A and we've got B. So now we can start filling in this table. As you can see, when we have a look at not A, we can look at our value for B as well. So not A or B, when we fill in the table, we can put 1s in these cells. So we've looked at not A, and because it's using an OR, we can remember have 1s in those columns which are 0s. We now look at B, or B. So whenever B is on, the output is also going to be true. So we can put 1s in these columns. Just note, if the square is already filled in with 1, there's no need for action on this, just like the top right hand square here. Here's your second example. See if you can complete this yourself. It's A or A and B. Notice how we've split this expression. Now what we can think of is A first of all. A, when it's true, is going to give a 1. So we can just write a 1 in that row. If we think of the output of A and B, you can see that A and B is only going to be an output of 1 when both inputs are true. So we can put a 1 into this cell. Now looking at what we just filled in, we can see there's a pattern here. And I want you to get into the habit of drawing a box round some of the outputs. So we can simplify this expression. What do you think this could give us? If we look at it carefully, you'll see that only when A is on, or 1, the input is 1, the output would be 1. So actually, we could simplify it just to A. Here's a much more complicated Karnaugh map. The steps are on the screen here to help you. Now you might actually want to write these steps into your notes so that you've got a clear indication and a clear method of how you would do this in the future. Try it now. So remember our first part of the method, split the expression into two parts by the OR. So we've got A and B, and we've got not A and B. So now we can start looking at each of the individual expressions. A and B, we know that we're only going to get an output of 1 when A is on and B is on, or the inputs are both true. So we can fill this cell with a 1. Next, we look at our not A and B and fill the cells that are true only when these inputs are true. So not A, so that's going to be only true when A is 0 and B, so when B is 1, so we can fill in this 1 which is shown on the screen. Once we're happy with this, we can start to group the ones together. And what does this represent? Can you try and guess this? In this instance, whenever B is 1, or the input is 1, it's true. So the answer can be simplified to B. Let's just have an aside. Why is it important to simplify logic gates? Remember, we can reduce the costs to manufacture. We can reduce the size of the components needed. We can reduce the power consumption and improve the execution speed. We're now going to have a little bit of a look when we've got 3 variables in a Karnaugh map. Now we can't have 3 columns, so we need to think about how we're going to arrange these now. For this example, we're going to be using A and not B, or C. We use the same method as before. We look for the OR and split it into 2 separate different parts. Now look at this example here. We usually have 2 variables together when we've actually got 3 inputs. And you can see the inputs here are 0, 0, 0, 1, 1, 1 and 1, 0. Now it's really important that we actually have our inputs in this order, otherwise the Karnaugh map will not work. We need 0, 0, 0, 1, 1, 1, 1, 0. So we go 0, 1, then we have 3, 2. Now, on first look, this looks a little bit confusing. We'd expect in this expression A and B to be together, and not B and C. But when we think about the expression and the use of the OR, we've got to be really careful about how we display these. Because we need to compare A to B in this expression, it's worth us having A and B in separate parts of the Karnaugh map. So we put B and C together. Now the first thing to think about is not B. And you can see not B is going to be all these areas highlighted in orange. The next thing to think about is where is A. So it's A and not B, and you can see A, and I put A across all the squares to help me to plan this. And here's our overlap. So you can see our overlap is here. That is a 1 in all the squares where A and not B are true. So you can see I've actually put a 1 in those different columns. But we also know this is going to be or C, so whenever 1 is true. So I can just write a 1 in the squares highlighted in orange. Here's our Karnaugh map. And we can now move on to the simplification of the expression, looking at our groupings. So these are the rules of the groupings. You need to write these down and make sure you memorise these rules. So group sizes can be 1, 2, 4 or 8. The groups can be overlapping. Each group must be as large as possible, and each one must be included in at least one group. We'll explain these as we go on. So going back to our answer, what's the biggest group we can find? Hopefully you've noticed that it's 4. There's a group of 4 that we can actually have there. We can't leave one in its own though. So we need to think about how we're going to include this 1. Now we can have a group of 2 as shown in the green box. Remember, we can't have a group of 3. It has to be 1, 2, 4 or 8. So we're going to put a circle around those 2. So now we can start to think about what each of these groups represent. Any ideas what the green group represents? So if we look at it carefully, we can see that the green group actually represents A, because they're both on that A input line, and not B. So if you look at the top, the first digit is the B, the second digit is C. So it's A and not B. And the blue group actually just represents C. Whenever C is on, this is actually going to be on with our output. So now we can put them together, and you can see here's our statement, A and not B, or C. There's no further simplification that we can do with this one. So now let's think of a massive expression. You can see here this is written. It can look quite intimidating to start with, but let's break the problem down. Can you see there are 4 expressions here, all separated by ors? That means we can look at each one as 4 different groupings. This is a real challenge. Can you simplify this Boolean expression? Pause the video now and see how you get on. So first of all, let's have a look at not A and B and C. So B and C have to be on. So you can look down that column where B and C are both 1. And when not A, well, not A would be 0, so we can put a 1 inside this box just here. Here's the second part, A and not B and C. So A and C both have to be on, and not B. So where B is a 0, C is a 1, and A is a 1. And you can put that value into our Karnaugh map. Here's our third part, A and B and not C. And you can see the value is in the final cell just here. And our final part of our expression, A and B and C, where all 3 are on, and that's going to appear in the red cell that's highlighted. The next stage to simplify it is to find the largest groups. Remember that overlapping is okay, and make sure every group is as large as possible, but can only be in groups of 1, 2, 4 or 8. How many groups can you see? In this instance, it's probably best to do 3 groups. You can see the 3 different colours that we've got. Can you figure out what each of the different groups mean? So as you can see, green is A and C. So A has to be on and C has to be on. If you look at that group, A is in the 1 column and C is in the 1 column. Blue is B and C. Purple is A and B. And we can just join these with an OR. So you can see the simplification that has come here. We can turn that massive expression into A and C, or B and C, or A and B. Now imagine the difference this would make in the amount of components that you would need to create this. There's a significant difference here, and it's much more efficient. Here's our next example. How far can you get along with this one? Let's review it. Not A and C is shown in red here. B and C can be shown here, so when B is on and C is on, so both are 1. A is easy. There's a 1 in every single cell, where A is 1. We look for our largest groups. We can find 2 groups of 4. And remember, overlapping is okay. So the green expression is A, and the blue expression is just C. So we can simplify this as A or C. There's one further grouping rule that we can think of. Boxes can actually wrap around the map. And the wrapping rule means that boxes can wrap from the right hand side to the left, or the top to the bottom edges of the map. So you can see this group here is not C. And this is why our Boolean on B and C needs to be starting with 0, 0, 0, 1, 1, 1 and 1, 0. What does this mapping represent? We've now got 4 inputs, A, B and C and D. Hopefully you figured out this is not B. Here's another example. What does this map represent? Pause the video and see if you can figure it out. Our first group is fairly obvious. There's a green group here. But there is actually one more group. Remember, every item needs to be in a group and we can't leave a one on its own. So our second group, we can wrap around the map. This is the blue group. What does the green group represent? So green is actually not A and B. You can just read across that row there, not A and B. That's when it's true. What about the blue group? This is a little bit harder. It's not B and not C and not D. That's actually the simplest way we can actually create that. So the whole expression becomes not A and B, or not B and not C and not D. So here's the final example of the wrapping rule. Can you see these 4 all actually have an item in common? These 2 are not D. These 4 are actually all not B. So we could have not D and not B. And I want you to have a go at the exam questions. We'll then have a look at some of the answers. You should now have completed the answers. Let's have a look at actually whether we were correct or not. So the first one is to state the Boolean expression represented by the Karnaugh map in its smallest form. Here you can see I've highlighted 3 different groups. Remember our grouping rules. They have to be in 1, 2, 4 or 8 in the largest group possible. Remember that we can't have a 1 on its own, we can't leave one out, and they can also wrap around. So the pink, if we look at this, we've got A and B at the top on this one, is A and B and C. When A is on and B is on and C is on. You just have to look for the patterns here. The yellow is not A and not D, and the green is not C, not D, not B. So we can put these together with ORs. Here was question 2. Again, a simplification. You've got A and B at the top and C and D on the left. In this example, you can actually see 2 groupings, not C and B. Again, a very similar kind of question. But this time we actually have to complete the Karnaugh map as well as completing the simplified expression. Here's our answer. We've got 2 groups, not C and not D, and B. So we've got B or not C and not D. Notice how we've used brackets just to help us to highlight these sections. Here's the final question. Find the Boolean expression represented by the Karnaugh map. We can actually find 3 groupings here. A and not C and not D, A and not B, and put those together with ORs. Again, a very similar question, but this time you've got to draw the logic gates represented by the Karnaugh map. Show your working. So let's find the groups first and then draw the logic gates. So here you can see it's not C and not A, or A and C. So when we're drawing these, we can do our inputs first. So we just need 2 inputs, A and C. The first one, we've got A and C, so we can draw those two together. That's going to come out to an OR. The other side of the OR is the result of not A and not C. So we need our AND, both of those knotted before the AND they go into the OR.